Alright, welcome back to part 4. In this part, we're finally going to transition to cameras that we spawn as we go. So, whenever a situation like this occurs, we will spawn a camera somewhere. We'll figure out where and how to spawn it in the course of this video. Might take another tutorial. We'll do a basic first, and then if it's needed, depending on how this one ends up, we might do another iteration using maybe a it's really just an excuse to show how to use recursive functions. Alright, so we'll maybe try that as a separate entry. For right now, going into the first person and coming out and going back in had the issue resolved if you follow the previous tutorial. If you don't, links in the description. They're all part of a series, so you should be good with that. Okay, let's get started on this. So we left it off at having the so this is the character camera. Let's get out of that. This is the external camera. So inside the external camera, we have the event tick running. We can delete those. So the event tick is running, and we also now have the index value of the camera that we can always get. So we can get the camera ID. We're getting that value when we transition into the end overlap. We might as well save it into this blueprint, but this blueprint is actually for excuse me, the external camera. The external camera is bound to be destroyed, so we don't really want to do it here. Inside this blueprint, we do not yet have a tick event, which is good, I suppose, but we need to create one, and so let's go and do that. I'm going to add a new event graph because I almost never do that. There. So we have the event tick. Now we need to do something with that, obviously. So when we go into the wall and we have this happening here, the spring arm, which is in use, is being affected and modified, and the camera of the camera distance of the actual camera and the spring arm is different. So we can get the owner. Remember, for this one we need a reference to self. From the owner, we can try to figure out what spring arm is in use. We can do that by get component by class and then spring arm component. And like before, because this interface is running all the time, it's running on tick, that spring arm, maybe we just need to add, because it's called camera boom by default, maybe we add a tag to it, is what I'm saying, just like we did for the head. And then is third person. We'll just call it third person. And instead of get components by class, we'll do get components by tag, just like we did for the head. Paste that in there. We'll type spring arm component, and with this we don't need to cast. We just get 0 because we only have one entry that we know of, and we is valid. So if this value is valid, then we need to check that something. So the spring arm length effect is collision fix applied. So this function tells us whether or not the spring arm is being modified. If it is modified, then we let's promote to variable, and in fact, that is a good point. Instead of doing this here, we'll move this down and move this down as well, and here we'll do a begin play. And that should put it where we need it. So we're only saving this information once, instead of checking it every tick. Should be a little more performant this way. Okay, compile, save. On event tick, now that we have this spring arm, we check that the collision fix is applied, and if the collision fix is applied, we want to get the spring arm again, and we adjusted is probably fix get unfixed camera position. Okay, so we have the camera position, and then from this one we can actually get the child. Get child component. Is it though? Is it referenced like that? Get. Yeah, it has to be. Child is a child, right? Child at index 0 is valid. Let's do a print string. Go check it. Okay. So because it's always valid, maybe we don't even need to check it. I mean, if we do an is valid, we avoid possible errors. Because I'm publishing to the marketplace, that matters. They don't let you not put that. Okay, so we have that. If that is valid, we can actually get the camera position and get world location. And then between those two, we do a distance. So that tells us how much the spring arm was compressed. Now if we take that spring arm option again, and from it we try to find the arm length, and let's say that we want to trigger everything when this is about 2/3 of the way down. So we divide by 3, multiply by 2, or you could do times 0.75. 2. So we have this. That's our comparison. If this is greater than that, we can now start triggering things. So in the first place, let's do, so we have the spring arm here. Let's do a spring arm rotation. Get rotation. And then I want to avoid the vertical incline, so get rotation from X vector, from right vector, up vector, forward vector. Get rotation from X vector. So this should be our value to use. We'll check that in a second. If it's true, we'll do a line trace by channels. We will use the spring arm or the owner. We will get the owner location. Get location. That's our starting point. We need to add vector plus vector. We have this rotation from X vector. We can multiply it. Let's just do vector times float. Let's start with 100. That's 8 meters. Let's see where that takes us. For the debug, I will set to persistent so that it will trigger no matter what. I will go into here, and there you go. Okay. So it's tracing to me, which is why it's hitting the wall. Perhaps this was not the best idea. Get world rotation, get forward vector. I will split the struct bin and split the struct bin here, and simply ignore the Z because I don't like it. I'll set this to 0.35 because I figure that 3.5 times 800 is a fairly large number. I mean 0.35 times 800 is a fairly large number, and that should get us vertically in the opposite direction. Except for the fact that seems like the control rotation is not so for whatever reason my rotation forward vector is not correct. So I could recombine it back up. It might be because of that. Yeah. Control. Okay. Let's try that. From here, get owner or get player controller. Get control rotation. Because the spring arm is tied to the control rotation by the variable, this should work. Get the forward vector of that, split it again, and connect it again. Alright. It is now casting away from us where we are looking. So obviously if we do it over here, it will cast over there, which is not ideal, but it's still not as bad as clipping into the character, falling to the floor, or doing other things. Obviously when the camera is outside, we have no issue. If we get a hit result, we know that is bad, so we won't be using this line trace. This is our starting point. So the camera will be placed somewhere on one of those green lines, and we'll make sure that this is disabled so that that doesn't happen either. So I'm not sure how to do that offhand. We'll figure it out. Move this here, zoom in here. Let me just have a second look at to see how much the distance is, if 800 is enough. So the camera from here to there, that's pretty far away. The spring arm is only set to 300, so if we do something like 300 here, we will match the spring arm length, and we can even just do this and make it dynamic so that we bounce the camera back around by however much the spring arm is set to. Okay. So now that that's happening, let's close the third person character. Let's leave only this open right now. Makes it easier. Okay, so we have the line trace. We have the return value. We branch to check that the hit did not occur. And if the hit did not occur, we can spawn actor from class BP external camera, and from here allow destroy to through so that we can make it get removed. For the spawn transform, we'll split the struct bin. We have a starting point and an end point. We want the end point really. I'm really just trying to create a reroute node, man. Driving me insane. I will also add a pin here because this is going to end up getting replaced into a recursive function eventually. So the transform scale is fine as it is, I think. The transform rotation, so we need to figure out the rotation. We have an endpoint, and we have the character location. So let's make some room in there. And then from this value and this value, we'll do a get look at rotation, find look at rotation. Let's align all of those. Type it into here and connect that to the rotation. We can bring those back just a tad and compile and save. And we need to disable this from happening and happening and happening, or we will just keep spawning an endless amount of cameras. So let's check on how we do that. So the transition here happens as soon as the camera is spawned. We have the collision. The collision takes place. The collision takes place on the cone. The overlap on the cone happens, and when the overlap on the cone happens, we have the overlap actor being set, and this starts happening here. It's probably best to just disable it locally so that it does not rely on that to prevent issues, because it's always running on tick, so you know. Also, yeah, the spring arm is set. But then we also need to check that it is valid again, huh? Because otherwise it will be whatever the blank value of that is, which would make this probably error out. So for what it costs, you just add another is valid. Call me paranoid. So if this value was true, if this value was false, so let's just prevent it by adding a local variable. Let's go with a bool. So I have it called dynamic external. If this value was false, we will set the dynamic external to true, which will then spawn and set everything up that way. Let's try it the other way around. That's true, because I'm looking away rather than towards. So the endpoint matters. Here we go. Go away and it disappears. The reason it's not happening again is the fact that we didn't reset the variable. Along with the fact that it would probably did not delete the original one, though we did set it up to delete, and I did see it disappear. If you look in this corner over here, as I redo this, you'll see it pop in and then disappear. You'll see the extra external camera, I move away, and deleted actor. So we know that's working, we don't need to worry about it. We just need to figure out how to re-enable this after the transition has occurred. So luckily we have the rest of the implementation here, and if the camera has transitioned, so we reset that value when we get to where we want to get to, we reset that value. Instead we add it to the other section so that we reset this value only when we end up into the first person camera again. And then because of that, it won't keep triggering over and over. It will just be there once and then come back up and then come back up, and we just made ourselves the dynamic camera. I think that was the shortest tutorial of the section, and it's not without problems, but the fact that we're using the line trace prevents us from having situations where a more corridor maybe might affect where the camera should be placed. So if we go into this section, which is really tiny, you should get responses that make sense. That's the outer camera actually. You can see it's actually not working badly at all. So this is the situation I wanted to check. This is not spawning because we are getting hits all over the place, and then that's also another situation we need to address. So let's try and address this situation first, because it's really ugly. So I would say that we just prevent this from happening when the... Okay, so to do that, the easiest way that we have is to get the child component world location, which is individualized, or will be, and compare it to something, and for it to be individualized so that you can be anywhere in the world. What travels along with everything else? The owner. So we get the owner location, just like that. And if we get the distance, we have a hairy situation because the distance could be positive or negative, and it will just be a distance. So let's split this truck pin up instead, and inside here we'll get the Z only. We'll subtract, because this is the point on the actor is usually around this mid-waist, I think. Well, let's take down like 30 from it, and then we'll compare it. We'll only be calling this if the value of the spring arm, Z, is bigger than that. Also, spring arm child component, yeah, the child component of the spring arm is the camera. So yeah, that makes sense. We need to plug it into there, so we add another pin for the end statement. Let's do another preview before I so this is what happens now. Well, not with the empty pin, that is. So this is what happens now, and we can go, if we are careful about the transition there not catching me, we can go up here and that will still happen up here as well. So now we add the end and we connect our pin over here. Bit of shuffling, and maybe a little repositioning there. Compile, save, go into here, and this will no longer happen now. But let's make sure it happens when we're here. Good. And let's go make sure it doesn't happen when we are at a different distance than we expect to be. Good. And let's make sure that it happens when something like this happens. Great. See that? Perfection. Alright guys, thanks for watching this tutorial series. In the next video I will definitely work on fixing whatever this is.